Hello there, and welcome to our video on the number of solutions for a linear system. So remember, for linear systems, everything that we're going to have is going to be a straight line. So first, what we're going to do is we're just going to kind of brainstorm and think about the number of solutions that you could have. And in a previous video, we had said that the number of solutions on a graph anyways is where the lines are going to intersect or cross. So try to maybe on your page just draw some lines going at different angles and different places and see how many times you could get them to cross. Maybe it's no times, 1 time, 2 time, 3 time. Just kind of brainstorm and come up with some ideas. So for this, I'm not even going to draw a full graph. I'm just going to draw some lines just to get some ideas, and then after we'll look at the actual graphs. So you could have maybe 2 lines like this. They're going side by side, and they have the exact same slope. So those lines, they would never cross, so there'd be no intersection. So something like that, there's going to be no solution. You could have maybe something like this, where you got a line, and then you got another line, and it's at a different angle, so then they do cross. And then at that point right there, that's going to be the solution. Or you could have maybe, say, this line right here, and then you have another line, but it's actually just the exact same line right over top of the other one. So at every point, it is intersecting or crossing it. So that one would have infinite amount of solutions. So we had just found, kind of brainstorming, there's going to be 3 types of solutions. You could have no solutions, 1 solution, or infinite solutions. So that's what this says right here. A system of linear equations can have 1 solution, no solution, or an infinite number of solutions. And we can actually find out how many solutions we get without even drawing the whole graph. So it says you can predict the number of solutions for a linear system by comparing the slopes and the y-intercepts of the equations. So for this first one, we have 1 solution. So these lines intersect. So you got one going like this, and then another one like this, and you can see they intersect right there. So they're going to have 1 solution right there. And what we could notice from this is that these have different slopes. So if they have different slopes, they're going to cross at some point. So I just got that written here. Different slopes, and the y-intercept, it actually doesn't matter. It could be the same or different. But as long as they have different slopes, you're going to have 1 solution. The next scenario is when you get no solution, and this deals with parallel lines. So if you have parallel lines, that means they both have the exact same slope. So they both have the same slope, and they have to have a different y-intercept, because we're going to see in the next case, if they actually have the same y-intercept, we get a different type of solution. So same slope, different y-intercept. Here's a y-intercept, and here's the y-intercept. So the last case is the infinite solution case. And these lines are called coincident lines. So you could think of it like, oh, what a coincidence. They're actually just one line right stacked on top of the other. So you actually only just see one line. So with this one, there actually is another line, but it's literally hiding underneath it. So you actually only end up seeing one line. So they have tons and tons of intersection points here. They're crossing literally everywhere. So that was because they have the exact same slope and they have the same y-intercept. So they got the same slope, same angle, and they both cross right at the same spot. So now that we know those 3 scenarios, we're going to be able to predict the types of solutions that we're going to get without even solving. And that's exactly what we're going to do in our first example. So it says, without graphing, analyze each system to determine whether the system has 1 solution, no solution, or an infinite solutions. So we aren't actually going to totally solve these. We're basically just going to find the slope and the y-intercept, compare them, and then see which scenario it is. 0 solutions, 1 solution, or infinite solutions. So in order to know what the slope and the y-intercept is though, we're going to need to convert into y equals mx plus b form, and then after I can compare the slope and the y-intercept. So I'm going to start with that left one first. We got 3x plus y is equal to a 10. And then to get the y by itself, I'm going to subtract 3x from both sides. Then the 3x will cancel, and we get y equals, and then I'm going to put the minus 3x first, and then the plus 10 second. So I can see from this that my slope is that number right there. So my slope is equal to a negative 3. And then this number right here, that is my y-intercept. So my y-intercept is equal to a positive 10. And then I'm going to do the same kind of thing for the other equation. So that one I had x minus 2y equals 1. And I'll first subtract an x from both sides to get rid of the x. So the x's cancel. And then I have minus 2y is equal to, put the negative x first, and then the plus 1 second. And then divide in front of the y by negative 2 to get that to go away. Do the same with your other terms. And then these are going to cancel up in front. And with this in the middle, the negative and the negative are also going to cancel. So what we get is y equals, it's going to be positive, and it was an x. And really there's like a hidden 1 here. So it's 1 over 2, and then x. And then here we had a plus and a minus. So that's just minus 1 over 2. So this one I can see my slope is right there. My slope is equal to a half. And then my y-intercept is that last number. So my y-intercept is a negative half. So in this case, one has a slope of negative 3, the other one has a slope of a half. So if ever they have different slope, that means they are angled at two different directions, so they're going to cross somewhere. So we're going to get one solution. So let's write that on the side. They have different slope, which tells us that there's only going to be one solution. Moving to the next one, we're going to do the same thing. So we're going to try to get this y by itself. So I am first going to subtract an x and then subtract an x. And I'm also going to subtract a 6 to get rid of the 6 and subtract a 6. So what I end up getting is minus 2y on the left equals, and then a minus x and a minus 6 on the right. And then to get rid of that negative 2 in front, divide by negative 2. Do that on the other side as well. These negative 2's are going to cancel. These negatives here are going to cancel, and these negatives here are going to cancel. So we get y equals, those negatives canceled, and there was a hidden 1 there, so it's just 1 over 2 x, and then the negatives canceled here, so it's going to be positive, and then 6 divided by 2 is 3. So I can see with this one, my slope is going to be equal to a half, and then my y-intercept is the 3 there. So y-intercept equals 3. With this one here on the right, that one is already in the form y equals mx plus b. So I can see that this number here in front of the x, that is my slope. So my slope is equal to a half. And then the last number there, that is my y-intercept. So my y-intercept is equal to a 3. So comparing these two, they both have a slope of a half, which means they both have the same kind of angle. And one has a y-intercept of 3, and the other one has a y-intercept of 3. So these are essentially the exact same equation. Y equals a half x plus 3, y equals a half x plus 3. So if they're the exact same equation, they're the exact same line, that means that they have the same slope and the same y-intercept. And if that happens, then that means they're overlapping everywhere. So we could say, therefore, it's going to have an infinite amount of solutions. We got one more here at the bottom, so we're going to do the same thing, get them into y equals. So I'm going to minus 3x from this to get it over to the other side, minus 3x. So I'm going to end up getting just 4y on this side. Then on the other side, I'll have minus 3x and a plus 12. And then let's get rid of the 4, so we got to divide by 4 on all of our terms. These 4's will cancel, and we get y equals negative 3 over 4x. And then 12 over 4, that's just equal to a 3. The second one, we're going to change this one too. So it's y equals negative 3 over 4 x. And then there was nothing after that. So really it's like it was a plus 0. So looking at both of these now, I can see this one, my slope is equal to negative 3 over 4. The y-intercept is right there. It's just equal to a 3. On this one, my slope is the same as the other one. It's negative 3 over 4. And my y-intercept is equal to a 0. So comparing these, this one has a slope of negative 3 over 4. This one has the exact same, but the y-intercepts are different. So if I just drew a quick graph of this, we're going to have one where it's going like this, and then another line where it's going like this, and they have different y-intercepts. One's here, and they have the same slope. So we can see those two lines, they never cross. They have the same slope, but different y-intercepts, so they never cross, so that means there's going to be no solutions. So let's write that. We're going to write same slope, different y-intercept, therefore no solutions. Moving from there, we have one last example. So this one says we got 4 vehicles, they're traveling on a straight stretch of highway, and their current distances and speeds are shown in the table below. So we got a car, a van, a truck, and an RV. The car is at the 40 kilometer mark, and it's going 90 kilometers an hour. The van is at the 25 kilometer mark, and it's going 90 kilometers an hour. And then we got some values for the truck and the RV. So for part A, it says for each vehicle represent the distance-time relationship using a linear equation. So we want to figure out what the equation is, and depending on how long we drive, that's going to determine how far we've traveled. So the number of hours that we've gone is going to be important. So that's why I labeled on the side here, N is going to be our number of hours traveled, and then D is just going to represent our total distance traveled. So we're going to start with the car first, then we'll do van, truck, and then the RV. So starting with the car, if you wanted to figure out how far you've traveled, we know we've already gone 40, plus we're going to be moving still. So it's going to be 40 plus, and to figure out how much further you've gone, if you go 90 kilometers an hour, and let's say you went for 2 hours, that would be 90 and then another 90, or it'd be 90 times 2. So we got to take this 90 and multiply by the number of hours that we're going to be traveling. So it's going to be 90 times n. So our equation for this is going to be 40 plus 90n. And then I'm just going to rearrange it so that I put this first, just because we normally like to put the variable first. It looks more like our other form. So we got 90n and then plus 40. So we're going 90 kilometers an hour, plus we already started at the 40 kilometer mark. For the van, it's basically going to be the same thing. We're going to add them and multiply by n. So for the van, we're going to get this right here. And I'm just labeling these with different numbers so I know which one's which. So 1 will be for car, 2 will be for van, and then I'll have for the truck will be 3, and then for the RV it's going to be a 4. So for my truck it's going to be 30 plus and then 110 times n. So that's going to give us this equation right here. I just changed the order. I put the 110 there first, and this one is using a 3. And lastly we have the RV, so it's going to be 40 plus 90 times n. So we're going to get this equation right there. I just changed the order again. So in part B, what we're going to be doing is we're going to be taking 2 vehicles out of this list and we're going to be solving their system. So what that means is we're going to be basically seeing where they cross or if they cross paths. So some of these you can kind of think about in your head and you know whether they're going to pass or cross each other at some point. Like if you had the car and the van, and this will be our first example actually down below. If one starts at the 40 kilometer mark and one starts at the 25 kilometer mark and they're both going the same speed, that means that this van is never going to catch the car because the car started with a head start and they're both going at the same speed. Whereas if you had like a truck, the truck is starting behind, but the truck is going faster, so the truck will eventually catch the car. So let's actually look at and solve some of those now. So it says, suppose the vehicles continue at their current speeds. Identify and interpret the solution to each linear system. So I've just written the equations that we had up top. For the car it was this one, and for the van it was this one. So just by looking at those equations, we can kind of reason in our head, but using our new stuff that we've learned, we could say that they both have the same slope. They both have a slope of 90, so they are increasing at the same amount, but one has a y-intercept of 40 and one has a y-intercept of 25. So they have same slope, different y-intercept, so that means they're going to have no solution. So same slope, different y-intercept, that gives us no solution. And that'll mean that the vehicles will actually never pass one another. Next, we're going to look at the car and the RV. So with those ones, the car was going 90 kilometers an hour, and it started at the 40 kilometer mark. The RV was going 90 as well, and it started at the 40 kilometer mark. So these equations are exactly the same. So essentially they started at the same point at 40 and they're both going 90 kilometers an hour. They're traveling at the same speed. So they start beside each other and they're just going to keep driving beside each other. So in this case they both have the same slope and the same y-intercept. So we can say that, same slope, same y-intercept. And then because of that, that means that they have infinite solutions. So they're basically just driving right beside each other the entire time. And the very last one we'll look at is the truck and the RV. So here are two equations. The truck is going 110 kilometers an hour, starts at the 30 kilometer mark. The RV is going 90, and it started at the 40 kilometer mark. So the truck is going fast. It's eventually going to catch up and pass the RV because it's going faster. So they have different slopes, different speeds, and they have different y-intercepts. So we said if they had different slopes, no matter what, if they have different slopes, that was going to give us a particular solution. So we are actually going to find that solution. So we're going to use our graphing calculator for this. So you can turn on your calculator, go into y equals, and then we're going to put in each of these equations. So the first one was 110, so 110, and then we used n, but in our calculator we have to use x. So we got x, and then plus 30, and then we can click enter, go down to our second equation, and we'll type this one in. So 90 times x instead of an n plus 40. Then we want to look at our graph, so click graph, and we can see it's graphing. We got one line going like this, and then we kind of had another line there, but they're really hard to see. So a good option to always kind of first try is click zoom, and then down below here, if you scroll all the way down, there's going to be one called zoom fit, and it's option number 0. Just make sure you check with your calculator, but for me it's just always 0, so I can click zoom and then 0, and then it'll reform the graph to try to show it as best it can. So we got our one line, and then our other line comes and crosses. So I see we got a crossing point. To find that, I'll click second, trace, and then intersect is number 5. And then as long as I only have 2 lines in here, it'll ask for the first curve, the second curve, and then if you want it to guess. So we can just click enter, enter, enter. And we get x is 0.5 and y is 85. So let's just write that down. We get our solution, 0.5 and 85. And instead of using x, right, we used n. So rather than this first term being an x, that is actually n. So that is the number of hours, and then the 85, that is actually d. So to interpret what this actually means, it means that after 0.5 hours, they are both at the 85 kilometer mark. So let's just write that. After half an hour, or for driving for 85 kilometers, they're both going to be at the same spot, which means they are going to meet or cross paths. So that was our last example. At the bottom here, I just got our textbook questions. So it's on page 455.